The cotangent function is not invertible until we restrict the domain. So look at the cotangent function. We know it is periodic, so it cannot be invertible. So we want to look at a smaller interval such that the function is one-to-one. So let's think the cotangent function is decreasing from 0 to pi with 2 vertical asymptotes. And then if you have more, if you have the usual cotangent function as periodic, just draw a few more branches, then it cannot pass the horizontal line test, right? You see horizontal line will intersect more than once with the cotangent function. So it's not one-to-one because of that. And then we want to consider only this. That is a cotangent function over this particular interval from 0 to pi. And then we're able to find its inverse because now it is one-to-one. Yeah, you can use a horizontal line test and you can clearly see it's a one-to-one function. So this function, it has an inverse. Now we look at this cotangent function. This cotangent function, its domain, it is from 0 to pi. The range, all real numbers. See if can be any real number. It's the set of all real numbers. And if we do inverse to this cotangent function, we will denote the inverse function as COT, cotangent. You see inverse, we put or sometimes we call it arc cotangent, right? Either way is fine. So this inverse cotangent function is written as a different name. We put a -1 on the top right top corner. And then we know the domain for the inverse will be the set of all real numbers. And the range for the inverse will be from 0 to pi, open parentheses, right? Because 0 pi, so that's open parentheses. We need to make sure that we write this domain for the cotangent is from 0 to pi with open parentheses. Because at 0 and pi, the cotangent is undefined. So we'll make sure this writing is precise and correct. Okay, so now that's why the range of the inverse of cotangent is 0 pi. Now we're ready to do a sketch. Sketch for the cotangent curve starts from some sample points for the tangent. So for the tangent curve, we pick some points from 0 to pi, but not including them, right? So that this must be those x values from 0 to pi, but bigger than 0, less than pi. So we pick this point from these different x values that are in this range, bigger than 0, but less than pi. So those are the x values we pick. They're all special values because at each x, we can find exact cotangent value. So cotangent at each of these x values can be found. Here we have a table. At pi over 6, cotangent is 1. At pi over 3, cotangent is square root of 3 over 3. At half of pi, the cotangent is 0, and etc. So at 3 pi over 4, cotangent is -1. So once we find this, we can find, so each ordered pair is a point on the cotangent curve. Then we know that we can find 5 ordered pairs for the inverse cotangent curve. Just for the inverse function, when the input is 1, the function value has to be pi over 4. So we just see. And for the inverse, when the given value is square root of 3 over 3, then the value has to be pi over 3. So this is each point, same reason whenever you have a b on the function, the BA must be on the inverse of, right? For as long as you find a point on the original function, then the BA will be a point on the inverse curve. So that's how we find 5 corresponding points on the inverse. And quickly we plot these 5 points, and then we can get a sketch of the inverse cotangent curve. Why do I want to rewrite this again? It's just for the convenience, because you see for these different axes, right? And we want to put, okay, what if the x from small to big, you see, gradually to the big. So yes, that's just same 5 points, and we arrange them so that the x coordinates is increasing. So still this first point is here, and second point is here. And so just rearrange the list of the 5 points, and so that the x coordinates increases, right? So we can see when x increases, what happens? The y is the what? The cotangent. So decreases, so that we can recognize the cotangent inverse is a decreasing function. So just like a cotangent curve was decreasing. So you can see the cotangent curve from 0 to pi. From 0 to pi, the cotangent function is decreasing, right? This is 1 period, and next period will be, yeah, contrast to the tangent function. Tangent at each cycle is increasing, but cotangent is decreasing. So this is cotangent. Of course, we only look at one branch, so we can see for this one branch, it's strictly decreasing. And if we look at more than 1 period, then it's not decreasing, right? It's only when you restrict to this interval, it's decreasing. Then just look at the inverse. The inverse function, which is symmetric with respect to this original function with respect to this curve, y equals x. So we can see the inverse function is also decreasing. So here is the inverse. This inverse function is also decreasing. And inverse and the original cotangent, and they are symmetric about the line. And then the 5 points are showing here on the inverse. And then now let's do some evaluation of the inverse cotangent. So the first is cotangent inverse at square root of 3. And so you are looking for a y. And this y is the range of the inverse cotangent. Notice it has to be a y from 0 to pi, right? From 0 to pi. So we're looking for a y, which is in this interval, whose cotangent value is square root of 3. What is y? And the square root of 3, you see, the y is actually, we can know the exact value because of the special angles we memorized. So it's pi over 6. Now, second question. So you want to evaluate inverse cotangent. Okay, arc cotangent, which is also written as, that's just a different name for the cotangent inverse. We have used this more than once, so now we're more used to it. So just get used to different names for the same function. So arc cotangent at 1. So what we're still thinking, this y is it is a value in the range, right? This value is in what? This interval. So what is this particular y if we want to evaluate? This is a value of the inverse cotangent when the input x is 1. So this particular y must be, must satisfy this. Cotangent y is 1. So what is y? Think from that interval, what is the y? So pi over 4. Pi over 4, whose cotangent value is 1. Yeah, so we got, that's the answer for the second problem. So this value should be pi over 4.